I feel like doing a kit build today. This little audio amplifier kit here. It's based on the TDA 2030 amplifier chip, that guy there, and it's just a little audio power amplifier. I used to do a lot of work with audio back in the day, and I just like a simple little kit like this once in a while just to play with. Oh, before I get carried away here, Corsair Brown Ale, because I know somebody's going to ask, an English brown ale from Quebec. Of all places to find an English brown ale. And it's quite nice, actually. Anyway, where was I? Oh, yeah. The circuit. So you can see here that they've just represented it like an amplifier block, like an op amp or whatever. Except for it's good for 15 watts according to this, or 14 watts or something like that. Anyway, so basically we've got a DC block capacitor coming on the inside to the non-inverting input. The inverting input has 100k feedback resistor with a bit of a voltage divider to ground. The input has a couple 100k to ground and 100k to the positive rail. Interesting. And then just a little filtering capacitor in there, another filtering capacitor down there, 10 ohm load resistor with a DC block, and another DC block going out to the speaker. Not much going on. We have on the DC input blocking capacitor, or blocking resistor rather. That's not a thing. Hang on. Okay, that is in fact a DC steering diode to make sure that we don't get reverse voltage on this guy. Right. And then a big capacitor and a little capacitor just to do some DC filtering, because you don't want any hum and crap coming in from your power line getting induced into your circuit here, do you? No, you don't. Do we want to know more about this little amplifier guy before we get into this? Sure. Let's just take a second and look at the data sheet. So here it is, the TDA 2030 14 watt hi-fi audio amplifier. Supply voltage up to 36 volts. You can either use a single, which is positive and ground, or a split, which is positive ground and negative voltage. So it is a Class AB amplifier, which Class A is probably the cleanest type of amplifier, but it's not the most efficient. Class B is much more efficient amplifier, and AB is kind of somewhere in between. At plus and minus 14 volts or 28 volts single-sided, it can do 14 watts into 4 ohms. Oh, sorry. It can do 12 watts into a 4 ohm mode and 8 watts in an 8 ohm mode. Okay. That's reasonable enough. I mean, we're not trying to do concert sound here. So here is just an example circuit using, what is a single-sided power supply? Yeah. Which actually, minus these diodes here, looks quite similar to the one in our schematic, or that came with our kit here. And there's a test circuit using the dual-ended supply. There's negative voltage, positive voltage, and ground in between. But that's not what we're doing. Alright, so here is our kit components. And it comes with, interestingly enough, a little piece of heatsink thermal conductive pad, a little plastic top hat washer, and a screw for the heatsink. So how you do this, if you're going to do it, is you'd use that little top hat washer, put it in there. That way the screw can't come in contact with the metalwork. Put that in there. You could use that gooey heatsink compound as well. And then you screw that onto the heatsink. So now it's electrically isolated from heatsink, but it's in good thermal contact. But as I mentioned, I'm not going to do that. all the values are marked on the board, and pretty good silk screen on this side, tinned pads and solder mask. This is that fiberglassy stuff, FR something or other. I know there's a name for it. I don't really care that much. It doesn't matter. It's just the fiberglassy type of board. That's all I really care about. So let's clamp it up in this guy and get going. And I think I shall start with the resistors, just because some of these guys stand up fairly tall off the board, so might as well get the low-lying components first. As I'm sure I've mentioned before, I've got some colorblind issues, and these bluish kind of background resistors or whatever they are even worse to try and see. So that one is the 10 ohm resistor. So that's why I'm going to check them all with my meter. Those of you who have better eyes and can actually see these little buggers, then go for it with the color code. But because color is an unreliable source of information for me, I choose not to trust it. So what do we got here? That guy is 4.7K. So that 10 ohm resistor is this guy over on the load side. The 4.7K is this one that makes the voltage divider in the feedback circuit. That's going to be a little bit difficult stuffing those guys in there. Yes, that is. Oh, that goes. Okay, I think I'm going to slide that board over that way so that I can get that going. Oh, I should turn my soldering iron on here. Get him down where I can get at him nicely. Yes, I'm using the Faco Baku. No, it's not a Hiko, but it's got all compatible parts. I've been using this one for over a year and a half now, and I have no complaints with it whatsoever, even though it is completely fake. And yeah, it just does the job. Use my nice skinny MG 6040 solder here. Up the temperature. These first couple of resistors soldered in. So I noticed that for a while there were quite a bunch of people doing basic kit build videos, and it seems to have gone by the wayside for a while. I'm wondering if people just got tired of doing them, or they got busy in their real life, or if they decided that they'd prefer to get into the circuit board design game themselves. I noticed quite a lot of people doing videos sponsored by the various circuit board manufacturing companies lately. So, yeah, maybe that's what's going on. I don't know. I still enjoy doing a nice basic kit once in a while, just for a change of pace. So these four resistors are all the same, and they are the 100K, which I guess I should have known because that's all that's left for resistors. Do a gentle little bend here. I'll kink them off underneath the board just to make sure they stay where I've put them when I flip the board over. I'm still going to give them a nudge, but that's not super neat. Okay, there's those two. Actually, where's my pliers? I'm gonna just tug this guy a little bit. Just get him sitting down in there better. Need to bend these a little bit tighter to the body of the part, I think. These holes are just barely spaced enough to get at them. where does the fourth one go? Oh, up there. Okay. There we go. How about I zoom in a bit here? Got to be a bit careful though. I don't want to throw it out of focus. I don't want to push it so far back that all of a sudden I'm working at arm's length. You might tip a quick clean every joint or two here. Why didn't you solder? There you go. And yeah, I'm somewhat random on these guys. That's okay. They don't care what order they get soldered down in. These little amplifier kits would make a really good beginner project, or like inexperienced soldering through-hole kind of project. And I know that surface mount is the new hotness that all the cool kids are doing these days, but I think I mentioned already, I like a nice old school kind of circuit every once in a while, just for the fun of it. Somebody's probably going to complain that I'm clipping through the solder. And yes, if I was working for NASA, that would be verboten. But I'm not. I'm just some guy in his basement, tinkering away, soldering and drinking beer. Okay, that's the resistors. Let's get that DC steering or blocking diode in there. Slide the board over a little bit in the holder again so I can get at it easily. So one downside of these tiny little boards, it's kind of hard to get a grip on them easily with the components right near the edge. You can do it, obviously, and of course you don't need a soldering tool or a soldering holder like this. I've got a video that I did a while back showing a bunch of different options that I've got to hold a board. All of them are perfectly valid. Some work better than others. Some work better for some situations than other situations too. So where's these two little 0.01 microfarad caps? 0.01 104s. They are, one of them's up there in the DC cleanup, and one of them is here just as a DC block on the load side. Just drop those guys in. Wow, that was completely accidental, but I got both of the sets of lettering facing the same way. I don't bother myself about that. Some people get really concerned about it. Again, I'm not all that bothered, especially not for a hobby project. Close enough for rock and roll, which is probably a lot of what this little guy's going to be doing. There. Pretty those up and nobody would ever know. Okay, next largest thing, we have some capacitors. I've got to be a little bit careful. There's 222 microfarads and one 2.2. Just make sure that I've got two. There's a 22. There's a 22, and this one's a 2.2. They're physically a slightly different size, so it's not that big a deal. Now the negative side, towards the negative little indicator on the board. It matters on these electrolytic capacitors. And if you're not careful, you can cause them to overheat and erupt, which is spectacular if you have witnesses. It's not going to happen every time, and it depends on how they're applied in the circuit. Neither of these ones are right across the power supply. This guy, this big guy over here, is, though, right across the power supply. So if I got him backwards, he would make a loud noise and a smoky smell. Once again, proving the old adage that everything's a smoke machine if you hook it up incorrectly enough. So now then, here is the 2.2 microfarad. Goes in there. What's that one doing? Oh, that's the input DC block capacitor. Okay. So basically that's chosen so that it doesn't block the audio frequencies that we're interested in. But being a capacitor, it does block the DC. And there's another one in series on the output. Although it's a different value, it is this guy here, no, that's a 100. Okay, where does that guy go then? Oh, no, this one is the one that goes across the power supply. And it is, focused here, it is a 35 volt 100 microfarad. So that's the one that we have to be most careful about getting in the right polarity. There's the little bar for negative, and there's the negative stripe there. That's the one that would make a loud noise and a nasty smell. It is very spectacular when they go off, and it takes a few seconds, so you get a little bit lulled into a false sense of security when you turn the thing on and nothing bad happens, and then all of a sudden something bad happens. 220 microfarad capacitor, that is the one that's in series with the output as a DC block. Stuff him in there. We're starting to run out of components already. That was easy. Okay, I think before I put the amplifier chip on, the amplifier transistor module device, I will put these header pins in. I need 2 for the input, 2 for the output, 2 for power, and 3 spares. How nice. These guys, I don't think I'm going to be able to, yeah, they're not going to hold in there. Let's throw some of our old friend, the blue tack, on there. And the output up there. Well, that's awkward. Let's pick up those pins later. And the audio input pins over here. Originally, I was thinking that I'd just let this video roll with pretty much no editing, but then it occurs to me I probably want to test it, so I'm going to have to do a small edit to get that in, and I think maybe speed up a little bit as well. So those pins are slightly bent, which tends to happen on the boat from China. What to do? So I'm not sure whether you caught it when I was looking at the data sheet earlier, but there's a big watermark across that says that this is an obsolete part or obsolete information, at least from the original manufacturer, which is ST. Not that that matters, because I think there's other copies of it out there. I'm not even sure if this one is an ST. I should have looked closer at it before I started soldering it. Doesn't matter. Okay. That's everything soldered in. Take a quick look with the magnifier and just make sure everything's soldered in. Oh, that's splattery and ugly, but it's not shorting. So that's all I really care about. Everything's connected to where it should be and not to anything that's not supposed to be. I think that'll do nicely. Let's turn off the soldering iron and clean up the workbench a little bit and set up some tests of some sort here. Okay, I've got it set up with my little power supply here. I've got 12-ish volts on it. It's for 200 milliamp current limit, so it doesn't run away completely. Just nothing connected for inputs and outputs right now. And turn it on. 20-ish milliamps just idling. That's not bad. Hook up the speaker. You hear that? That's a good sign. All right, let's get some audio into it. Remember this guy from a mailbag previously? Let's plug him into the audio input. Turn it on. Ha-ha! Volume up. Nice! That's excellent. Let's crank that volume all the way up. I've seen a peak of about 150 milliamps. Oh, down, 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 down. Not getting especially warm. Okay. Let's see if I can find a nicer speaker than that one. That ought to do the job. That's loud. And not sounding very distorted either. It's sounding pretty clean. Cool. Well, that's a result. Wonder what else I can use. Let's try this. It's a horrible little guitar. Oh yeah. Where's a pick? That's cool. I like it. And I've got a little boost on this guitar here. Okay, so this guitar just being, I mean, it's tiny. Look at this thing. It will not stay in tune. This works pretty damn well. I'm impressed. And for just a quick little kit build, I don't know, how long did that take me? 15 minutes to slam it together? Maybe 20? Because I was talking? This is fun. I like this thing. All right, well, can I even reach my beer? Thanks for watching. That was fun. That was nice, relaxing little time here. Hope you enjoyed it. I'll talk to you later. Comments, questions down below. Yeah, you know.